Hey, Flip Geometry, how we doing? We are in the penultimate section of your textbook. We are almost done. Section 12.5, Trigonometric Identities. This almost end of your geometry book is where your pre-calculus life will begin. So take a good deep breath of this and let it soak into your soul because you will need it again in the future. Let's go ahead and get started. First, just a little quick note on notation. If you have sine of x and you need to square that, you don't write the square at the end of the expression sine of x because then you're saying it's the sine of x squared. We put the sine, we put the square at the end of the word sine so that it's clear that we're talking about squaring this function. Okay, so if you have to square the sine of x, you say sine squared x. Not sine of x squared. Sine of x squared means take x, square it, and then give me the sine of that value. Okay, so just a quick notation, and we'll move on from there. Here's your first trigonometric identity. So for sine squared x and cosine squared x, we're going to get those values for 30, 45, and 75 degrees. And then when you add them together, you're going to see that always sine squared x plus cosine squared x equals 1. That is our first trigonometric identity that we have here, and we're going to demonstrate it to you. So 30 degrees, the sine of 30 degrees is 1/2. 1/2 squared is 1/4. Cosine squared of x, cosine of 30 degrees is radical 3/2. Square that, you get 3/4. So 1/4 plus 3/4 equals 1. Sine squared of x plus cosine squared of x equals 1 for 30 degrees. And I won't insult your intelligence by reading it to you. It works for 45 degrees as well. You wind up with 1/2 times plus 1/2, which is 1. And it works as well for kind of a randomly chosen angle. 75 degrees, approximately 0.9330 and approximately 0.0670. You add those together and you get 1. So, all the time and everywhere, sine squared x plus cosine squared of x equals 1. So, any time that you can determine this, that any equation that is true for all values of the variable, we call that an identity. So, like theorems, identities need to be proven, but here's your theorem first. For any angle x, sine squared x plus cosine squared x equals 1. That's your theorem, and now let's prove it. I have some right triangle, ABC, and I have an angle A, and that angle equals x. So this is a degree measure of angle A in a right triangle. Sine of x is A over C. In this triangle, A is here, so this side, A, is the opposite divided by this side here, C, which is the hypotenuse. Sine is opposite over hypotenuse, right? A over C. Cosine of x is B over C. Cosine here is adjacent over hypotenuse, okay? A then equals C times the sine of x. If I just take this C and I multiply both sides by C, I move C over here. Same thing, if I take C and I multiply both sides by C, I move the C over here. So A is C times the cosine of x, and B is C times the cosine of x. That's the multiplicative property of equality. Then I have this thing called the Pythagorean theorem that I can pull out of the air and say I'm going to use that. A squared plus B squared equals C squared. That's the Pythagorean theorem. Here I have A, here I have B. I'm going to substitute them in. C times the sine of x squared, that's A, plus C times the cosine of x, that's B, squared equals C squared. That's just substitution into the Pythagorean theorem. And now I can square these things. So when you square a product, you have to square both parts of that product. So C squared sine squared x plus C squared cosine squared x equals C squared. Now I have C squared, C squared, C squared. I'm going to divide the entire equation by C squared and drop it out of all three places that it is. That's the power of a product, or you can say the multiplicative property of identity would also work. And I have sine squared x plus cosine squared x equals 1. That is all done, ladies and gentlemen. We have proven our first identity. This lesson is going to be a lot of proving identities, proving that sine x, cosine x, tangent x of something over here equals sine x, cosine x, tangent of something over here. So you're going to be doing algebra with trigonometric expressions. And there are some things that, some pointers here. So anytime you see sine x squared, sine squared x, you can substitute that with 1 minus the cosine squared of x, because this plus this equals 1. So 1 is this, 1 minus the other. And you can rearrange the other way too. So cosine squared of x is 1 minus the sine squared of x. So those things will come in handy. Also, if you have these things on both sides of the equal sign, there's two strategies. One is to transform them both so that they say the same thing, or just simplify the more complicated side down until it says what you have on the other side. That's the more useful tool, and we're going to do that together a couple of times. But first, let me introduce you to some new friends. You just made a new peer group. You knew sine, cosine, and tangent. They're your old buddies. You guys have gone to the movies together. But now they're going to bring their friends secant, cosecant, and cotangent along. And so these are new friends for you. Yay, nice to meet you, cosecant. What are you guys? Well, secant is the inverse of a cosine. 1 divided by a cosine is a secant. It's a inverse or a reciprocal. It's a reciprocal. That's a better word. Hey, look, there's the word. Okay. The reciprocal of a sine is a cosecant. So it's a little confusing because sine and then cosine, it would have been really cool if sine's inverse was a secant and the cosine's inverse was a cosecant. That's the way I would have done it if I were naming these things, because co would have gone with co. But unfortunately, the person who came up with this isn't that smart. So secant goes with cosine, and cosecant goes with sine. So fortunately, it's one of those times where it's perfectly illogical. So I just remember that it's perfectly illogical. And that's how I remember which one goes with which. Okay? The one that does make sense is that the reciprocal of a tangent is a cotangent. So a cosine on its head is a secant. A sine on its head is a cosecant. And a tangent on its head is a cotangent. Let's remember those as we go forward too. Here's an interesting bit of algebra. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. What happens if you divide a sine by a cosine? You have two division statements dividing each other, and what winds up happening is that hypotenuse disappears from both of those, and you wind up with opposite over adjacent. What's opposite over adjacent? That's a tangent. Really cool. So if you have the tangent of x, you can replace that with the sine of x divided by the cosine of x. This will be a helpful tool in your bucket as well. Now, if that is what a tangent is, remember a tangent standing on its head is a cotangent. So if I just invert these two, then the reciprocal of this is this. And so the reciprocal of a tangent is a cotangent. So the cotangent of x is the cosine of x divided by the sine of x. Are you confused yet? Don't worry, you'll get way more confused. Here's an example of what we're going to do today. Ready? Deep breath. Okay. Prove that the sine of x times the secant of x is the tangent of x. Okay, here we go. Ready? Sine of x times the secant of x. Well, secant is the inverse of a cosine. So let's write that way. Sine of x times 1 over the cosine of x, right? It's the reciprocal. I keep saying inverse. It's the reciprocal of a cosine. Sine of x times the secant, sine of x times 1 over the cosine. Now look at this for a minute and go, what is that? Here, sine of x, it's over an imaginary 1, right? Sine of x times 1 over the cosine of x. Well, I just can put cosine as the denominator under sine. This is an equivalent thing. Sine of x over cosine of x. What's sine over cosine? Go back a slide. Oh yeah, sine over cosine is tangent. Okay, so I have just shown that this equals the tangent of x. So When it says prove, you don't have the two-column proof where you have statements. They're talking about doing algebra in a logical step-by-step way. Always show your work, show every step, show me how this happens, and we'll stumble through this together. Here's another one. Prove that 1 plus the cosine of x times 1 minus the cosine of x equals sine squared x. Okay, that's fine. Let's do that. So here I have 1 plus something times 1 minus something. What am I going to do here? How do you multiply two binomials? You FOIL it. How? Rats! Foiled again. Yes. 1 times 1 is 1. 1 times the negative cosine of x is negative cosine of x. Cosine of x times 1 is cosine of x. And cosine of x times the negative cosine of x is minus cosine squared x. FOIL. There it is. Now I can simplify. Cosine of x minus the cosine of x. This is like 2 minus 2, right? So it cancels out. They add up to 0. So I have 1 minus the cosine squared of x. And if you remember a couple of slides ago, 1 minus the cosine squared of x equals sine squared of x. So these two binomials times each other equal sine squared of x. There it is. Play that again if you need to. Okay, so prove that cotangent squared of x plus 1 equals the cosecant squared of x. Here we go. This one is a little bit challenging. Cotangent squared of x plus 1. What's the cotangent? It's a tangent standing on its head. It's the reciprocal of a tangent. So you could start with 1 over tangent squared of x. That's not very helpful. Now, tangent, remember, is sine over cosine. Cotangent is cosine over sine. So cotangent squared x is cosine squared over sine squared. So I'd make cotangent squared x cosine squared x over sine squared x plus 1. Now, I need to get rid of this plus 1 term because where I'm going there is no plus 1. How am I going to get rid of this plus 1 term? I can make it something that I can combine up here in the numerator and make this actually one division problem, one fraction. But in order to do that, I have to have a common denominator. So how do I get this 1 to be something over sine squared x? Well, 1, any fraction that has the same numerator and denominator is 1, right? So I can take sine squared x over sine squared x and multiply it by 1, or I can just turn this 1 into sine squared x over sine squared x. So where's my mouse? Oh, I lost my mouse. There you go. Sine squared x over sine squared x. Now, I have a common denominator, cosine squared x plus sine squared x all over sine squared x. That's what I have here. Now remember what cosine squared x plus sine squared x is. Always is 1. That's the first way we started this lesson. So I can just simplify this to 1. Now I have 1 over the sine squared of x. What's 1 over a sine? What's the reciprocal of a sine? Cosecant. So a cosecant squared of x. Alrighty. This is not easy, I'm going to be honest with you, but it is also not impossible. If you take a deep breath and think through things, and you might take a couple of roads before you find the answer, this can happen. All right, folks. God bless your brains as we do this together. If you have any questions, put them in the comments field below, and I'll get to them as quickly as I can, or I'll see you in class tomorrow. Until then, God bless you. Jesus loves you, and so do I. Good night.